All right, students, we're into 11.4 homework. 11.4 says 1 through 8, 11 through 13. I guess I picked 17 and then 19 through 21. So I got some holes in here a little bit. First, you start off with, and shouldn't be a real surprise when we learn new terminology. We want to make sure we cover it. So what is this shape? Okay, now they will try at times so that it is a little bit, honestly, the book has gotten better in this respect. They have shaded the part that you would want to think of as a base. Personally, I think that's helpful because otherwise, sometimes you look at this shape that's right here and it's hard to see what's happening. So to me, you look at this, can I tip this right side up? Do I see something that kind of helps me to illustrate kind of what's happening? They've shaded one of them. I personally think it helps. I hope you do too. Okay. If you believe that it is marked as a right shape, go ahead and say that. If you can't tell or you think it isn't, make sure you say then oblique or just name the shape without either of those two. Next up, your goal. And this one, I think sometimes students read the problem wrong. This is not a question asking about just the number of cubes in the stack, although it does say find the number of cubes in the stack. You have to also assume that it's lying on a flat surface, which means when you see the two cubes here, one in front, one on top of it, the one on top has to be on top of something. So there has to be a cube underneath it, and it has to be a flat surface. So there won't be one like hidden behind as you go. Okay. So we're looking at something like that. And okay, so one thing is we're going to glue the faces together. So your goal is determine the number of cubes and the number of faces that are glued together. So just as an example, I'll jump over to another question right over here, question 9. And what you can do is say, okay, let me take a look here. So how many faces are glued together? Well, this little piece right here, there's kind of like a square between these two that is glued together. That is two faces that got glued together right there. And another two coming across the middle one here, and another two right in here. So 2, 4, and 6. So I got 6 faces that are glued together. Okay. So that's how you find the number of faces that are glued together. There we go. Next up. This also similar to, if you remember the activity we did in class near the beginning of the term where we looked at creating those sequences, like put a polygon, like put a pentagon, then put a pentagon next to it and kind of glue the edge together and then continue, and you'd glue an edge together and you'd see, talk about the perimeter of the outside shape. They'd have like two faces that are kind of glued together, two edges. It's very similar to what we're doing here. Next up, given the prism, they're telling you it's a prism. Name the following. Hey, what are all the vertices? What are all the edges? What are all the faces? Remember, a face is that three-dimensional shape. And what is the intersection of a face with an edge? What is an intersection of a face with a face? Again, from this, I think they did, this one's actually drawn pretty well, so you can kind of hopefully see that A, B, E, F is kind of the front, and B, C, E is kind of the top, if you will. Okay. Next up, how many lateral faces does an octagonal prism have? If you need to, yes, you can always sketch out an octagonal prism, but you could also say, what about a quadrilateral prism? How many lateral faces does it have? How many lateral faces does a triangular prism have? I think if you do a couple smaller shapes, you might be able to answer this question very, very quickly. The base of a pyramid has n sides. Oh, that's good. How many lateral faces does it have? And how many faces does it have? Now, please notice the difference. Lateral faces are the ones that go up. The face itself could include bases. Okay, a base is still a face. Determine the minimum number of edges possible for each of the following polyhedra. What is the smallest number of edges for a prism? Okay. What is the smallest number of edges possible for a pyramid? Now, if you need to, think through what's the smallest shape I could have for a pyramid? What's the smallest shape I could have for a prism? That's what we're looking for, the minimum number of edges. Okay. Classify each of the following statements as true or false. Ooh, interesting. Always, sometimes, never. The base of a cone is a circle. Is that always true, sometimes true, or never true? So again, these are just kind of true, false. So I'm not going to go through each one of those. And then question 8, for each of the following polygons, draw a prism and a pyramid with the polygon as the base. This is just your chance to practice, okay? And as you're practicing, realize if it doesn't say it's a regular pentagon, it doesn't have to be a regular pentagon. So you could make a shape that is a pentagon. This is a pentagon, and then copy that shape beneath it, right? So that we have the same type of shape, and then just connect those sides. Wow. Oh my gosh, that's like artists almost. And of course, in the back, when you kind of erase, use a pencil and you can kind of just erase a little bit to make the little dashed lines across the back. Yeah, that's all we're looking for. That's it. Practice. Practice doing those. Those are definitely meant to be fairly quick. Let's see here. So 1 through 8. Ooh, 11 through 13. So do not do that. Do not do necessarily an octahedron. 11 through 13 and 17. Okay. So 11, sketch a triangular prism. Cool. So right up here, these were, if you notice, this is a prism up here. Then it says sketch a triangular prism. Label one of its bases and one of its lateral faces. So up here, you're just getting used to sketching it. Now you're going to sketch it, put letters on it so you can actually label it so someone else can kind of read what you're doing. What is the relationship between edges and the number of sides in the polygon? Interesting. And it does say in a prism. So realize that's kind of important. Could a prism have 23 vertices? Could a prism have 17 edges? Think about what it means when you're kind of connecting these pieces together. Okay. And again, if you're struggling with that, I would recommend go back and make prisms. Make a triangular, make a quadrilateral, write down how many edges do I have? How many vertices do I have? And what's the connection between those? Okay. 13 here, the following figures represent cards. Oh, so this is a three-dimensional shape that you're going to create. And if you haven't seen these before, they're kind of cool. Take a string, it says a wire, but take a piece of string and tape a polygon or some other shape to it, and then spin the string between your fingers. And when you see it rotating, it looks like a three-dimensional shape. Your goal is to come up with the name of that three-dimensional shape. Okay. Sketch and name the three-dimensional shape. So as an example, if this was spinning, right, then here's my wire. This comes out, looks like this. Now, as it's spinning, so I'm going to thicken my line segment just a little bit, right? Then this piece is kind of spinning around, making an entire shape around the top, right? And this piece here is spinning around the base. And then maybe I'll do some dashed around the back. And so what I have is what looked initially like a trapezoid, which it did. When I spin it around, now it looks like this part got cut off. So I would say truncated cone. There we go. And probably truncated right circular cone if I was spinning it. But it gives you an idea of how to draw the sketch out. Okay. All right. 11 through 13. Let's take a look at the next page. These aren't bad. These are kind of slicing through things as you go. So let me skip down to number 17 and say here is a net. Think of folding this up. What shape are you making when you fold that up? And that is, by the way, it does say assume squares and equilateral triangles were used. So as you form them, it will be equilateral triangles only, which I think makes a little bit more sense. Okay. Let's see here. That was 17 and then 19 through 21. So this is a shape here. This is a net. You're going to fold that net up. And when you fold that up in your mind, I'll give you 4 options. Which object, which of these is going to actually represent this? So as you take a look, what does it look like? And the same is true for this one with the kind of weird, kind of shaded pieces. 19, here's number 20. Answer the following about a pyramid. This is now a pyramid with an n-gon as the base. And you also have a prism. So you're doing it for both. I would recommend kind of making a column. Here's my pyramid. Here's my relationships. Here is a prism. Here's my relationships. And it's not bad to think about doing this for what does a triangle look like? What is a quadrilateral? I think it helps you to start see the connection between vertices, faces, and edges for each of them, for a pyramid and for a prism. That's my recommendation. And a soccer ball is a polyhedra. Basically, of course, once you blow it up with air, it pushes out a little bit, so it looks rounder. But if you let it deflate, you're going to have these 32 faces. You have 20 regular hexagons and 12 regular pentagons. And the question is, how many vertices are there? And again, if you know Euler's formula, you can actually solve for that very quickly. It's the formula that's listed right above. Right. I'm not sure why it's not letting me highlight that, but it's not. So there you go. That is it for the homework on 11.4. If you look at the MCs, looks like 4, 5, 6, and 11, 12, 13. So not a ton. Looks like maybe 6 of those for this one. All right, I'll be back with that video. Off you go.